Hello everybody and welcome back. Welcome to our next project. Before we get started here and I introduce our next project, I'd just like to take a quick second to thank all of you. About the last video that we did, I made a mention that our cat, Cookie, passed away a couple weeks ago, and I was really shocked by the outpouring of kind words and comments and emails and so many things that I got, even some of you that shared some of your stories, of losing some of your friends, your furry friends. So I just wanted to take a quick second to thank you guys. You're living proof that there are still really good people in this world, and you're the reason that I continue doing this. I enjoyed doing it. So thank you all, and let's get on with the next project. What you see here, first of all, should be a familiar face. We have a model Sansui TU-X1 tuner. Never thought I'd see a second one of these in my life, and here it is on my bench. If you look back, any of you that watch my channel regularly, you'll remember that I did a restoration and alignment of one of these, and it turned out to be an amazing piece of equipment. Probably one of the finest built tuners I've ever worked on. And lo and behold, we now have the match set. We have its mate, the AU-X1 super integrated amplifier. So, we heard a couple years ago, I did a project called The Old Married Couple of the SA 9100 and TX 9100 Pioneer amplifier and tuner. And I think we're going to call this one the Big Married Couple because this sucker barely fits on the bench. So all 67 pounds of this one, and I don't know how much this weighs. It's probably 40 pounds itself just for a tuner. So we're going to focus mainly on the amplifier in this series. The last thing we'll do at the end is I'm going to go and also restore this. But since we already did a video on that, I may only put a couple snips on there if there's something that I do on this one that we didn't cover in the first video. So really most of this series is going to be about this AU-X1. It's a really unique amplifier, unlike anything that we've worked on this channel before. As you notice, there are no tone controls or anything like that. There's this unique little jump button, which the jump button actually has to do with the phono stage. There's some very innovative design features that went into this. Sansui engineers absolutely spared no expense or no effort trying to create the very best piece of audio gear they could create at the time. So this is going to be a really interesting project. So the first thing we need to do is get this bench cleared off. We'll get this guy put back away, and then we'll go get this thing apart. There's a lot of features, but it's really too much to just talk about in one shot here. So as we go along, we'll kind of mention some of the unique things of this, and we'll sort of look at it in the schematics as we go through it and test it, restore it, whatever we need to do. This is supposed to be fully functional. But of course, there are some quirks that are known to exist in certain versions of this, so I'm not going to take any chances. We're going to go very cautiously, as we always do, and I think this is going to be a real fun project. So stay tuned, and we'll get started. Well, if you were expecting to see anything more interesting inside, I guess this is a little bit of a letdown because you can see how heavily shielded everything is in here. Notice that there are two transformers. The big toroid transformer is for the actual output section, which is right here, and then the EI core transformer is for the linear power supply for the preamp, the phono stage, all those sorts of things, the low voltage. You can see two big banks of capacitors here and here, and those are actually your main filters for the output section, and then these ones are actually filters for the rest of the amp. You can see two great big heat sinks on there, and they contain 10 TO3 type transistors, but they're special ones. They're ring emitter type transistors. And when we start servicing this part of it, I'll get in a little bit more into what those are, what they mean, and what their purpose is. But they are different than just standard transistors. So to be able to see anything else, obviously we're going to have to start taking covers off. And really, you can tell by all the dust, this thing really needs cleaned up. So first thing I'm going to do is get this thing cleaned up and dusted. And then we're going to start taking some covers off, and we're going to start the restoration process. Well, as the dust is clearing here and floating around in front of the camera, you might ask yourself, or you might be asking, why am I just jumping right in and taking things apart and not actually turning the amp on and trying it out? Well, it has to do with a few things here. First of all, let's go back at the beginning here, and if we look at this serial number, this is the 238 serial numbers. These ones that start with 238 like this would indicate that this amplifier was built in 1978. This is the first year that these were built. These were built in 78, 79, and 80. 1978, 1979, 1980. And one of the problems is this 79 at the end, I believe, makes this, I would say, the 79th of these amps ever built, which means it's a very early model. Now, these amps are notorious for having some design problems, especially in the earlier models. And those design problems can be pretty severe with age. There are some capacitors in here, kind of in the same idea as that ADCOM that we did, the GFA 585, except instead of being electrolytics, they're actually a type of film capacitor. And they were a very flawed design. They're these little black film capacitors, and they will fail. In other words, they will internally lose their contact between the leads and the actual capacitor itself, which will pretty much make the capacitance go down to almost nothing. The problem is these capacitors are not really in the audio path as per se, but they are designed to prevent this amplifier from going into a really bad parasitic oscillation. When this amp goes into that oscillation, it's so severe that it will actually damage the output transistors. It will short them out. And the real problem with that is these output transistors are becoming unobtainium. They're very hard to find, and when you do find them, they're very expensive. The best bet is to not let them burn up. So being that this is an older amp, now the later models, they made some modifications to the amp to make it a little more stable and more reliable. They still used those capacitors, but there was a lower probability of that happening than on this one. So because of the risks involved and because of the rarity of these amplifiers, I am going to do something that I don't always do, and that is I'm going to actually really go through this thing and take it apart and check things before I even try to put much in the line of power to it. We have it on the word of the person who the owner of this purchased it from, that it's okay and it's fully functional, but I'm still a little bit nervous with something like that. So we're going to go through and just kind of check some things, and then we'll bring it up very carefully and just see if at least if it works. If everything works, then we're done. We're going to stop, and then we're going to just start replacing those components. So that's why. So here's an example of why I did not want to turn this thing on first. If you look right here, look at this hacked up bodge job of solder. This is soldered in here something, I don't know. It looks like these were cut off and then just tacked on. And if I back you up a little bit here, you can see that is actually the back of one of the power amplifier modules. It looks like an input signal, and I'm not sure what else. And it is all but touching this cover here. The same thing is over there. I don't know if somebody tried to remove these to service them and then they didn't have the proper tools to reattach these properly, but you can see just how bad that is. I mean, if I kind of get you up close. In addition to that, if you look down here, I don't know if you can see it from the angle that I have you at, and you look right here, there's something wedged down in there. Something fell down and is kind of stuck in there. So there's definitely some issues. In the phono section, which this whole entire thing is the phono section. This is the moving magnet right and left channel and the moving coil right and left channel. And you can see those black capacitors that I'm talking about, and they are so deteriorated that they're actually just flaking off as I touch them. And that's one of the problems of them. The other thing, if you notice here, is that glue, and this glue is actually dried out and starting to corrode and hardening. So all that's going to need removed and cleaned. What this all amounts to is I really am a little bit nervous applying power to this until we actually do some service on it. So again, we may have to do some things and then try it out, and you know, if we introduce our own problems, we'll have to troubleshoot them and repair them. But I think the name of the game here is not to do any more damage. So again, we are looking at you know, this stuff, and I don't know that I haven't even taken the bottom off, or I haven't taken the front cover off or any of that yet. But just giving you an example why you don't just go in and plug these in and turn them on. Okay, looking at the line stage here, you can see these capacitors and just how they're like getting all wrinkly and rough. Now see, this one here is nice and smooth and glossy. That's what they should look like, but that's what these things do. One here, this one's bad, and they go bad. You can't trust them. So all those are going to have to be replaced, and if I back you out a little bit, you can just see even in this line stage up front how many capacitors. There's just a zillion of them. So this will be this is going to be a big job to recap this and so forth, but it needs to be done. So looking at the other channel here, you can see where these wires are on the correct way. They've not been cut off and bodged on, resoldered and all that. That's how it should look. So, and then here's another one of those capacitors. So they're all over the place. Okay, looking at the bottom here, we got the bottom cover off. We can see the power supply down here. And once again, just like they bodged the wires on the other side, you can see the actual little snubber network on the output of the amplifier. You can see where they had that off, and they just kind of hacked it on there. It's almost shorting up here. This is all bent. And if you compare that to the other side that they didn't mess with, much nicer. So again, we're going to have to clean all this up. It looks like one of these amps this channel has been worked on or something, like they did some service to it or something. But we'll know once we get these up out of here. Well, I spoke too soon. Looking at this channel, you could see where this has all been pinched and bent and so forth. And you can see this wire, they cut it off and then they just tack soldered it back on. You could see how it's on there just flapping around. I don't know why you would do something like that. You look at all this extra wire they have. They could have stripped it and rewrapped it around here the right way. I just don't get that. And then I look over here on this side and look at that. My goodness, they cut this thing off and then just kind of tacked it on there. Same thing here. It looks like they pinched them really hard with pliers, so those wires are going to need replaced. this terminal strip's ready to fall off. This real heavy shielded wire here, this cable, these are the actual speaker cables going to the speaker terminals. So whoever worked on this didn't really do a very neat job putting things back together. Okay, a classic amplifier that's really high end, and look at the job. They cut the wire and then it wasn't long enough, so instead of just putting a new piece of wire from the whole way, they spliced in another piece. So you have one piece, a ball of tape, another piece, a ball of tape, and then going to the end. And that's only a wire that's, you know, that long. Unbelievable. All right, so here it is, the crusty pair. Yeah, they kind of did some damage to this one. If you look here. Oh, too far. There we go. So you can see where they got the track broke off here on both of these. I'm going to have to repair that and clean it. And if we back up a little bit here, there's more of those black capacitors, the bad ones. Really, the whole thing needs done. I mean, you look at the glue in there, it's that nasty, crusty glue. So this will have to come out and get all redone. So, and you can see the effects of that corrosive glue. It just completely disintegrated this diode and resistor here, if you look. And this capacitor here doesn't look very well either. It's kind of black on the bottom. And this doesn't have glue on it. These do. So that's all going to need removed and cleaned, and then these are going to need replaced. I'm probably just going to replace most of what's on this board. Some of the transistors might stay, but I don't know. I may even get rid of them while we're at it. Not sure. So yeah, we got our work cut out for us on this one. Alright, I'm replacing the transistors in this thing, and if you notice, they use these little square nuts, and these really get tarnished, these screws. And the reason that's important on these ones is, if you notice on this, the center pin is actually cut off. It actually does not go down through the middle. So if you look on the back, there's only two holes. The collector is actually connected through the screw that's attached on the tab there. And the big problem with that is that this is so loose, I can almost loosen it with my fingers. And between the tarnishing and the loose screw, you're not getting a very good connection in there. So what I'm going to use is, I'm going to use these stainless steel screws. And I know stainless steel isn't as good of a conductor as copper, but it won't tarnish. And I'm going to use these star nuts here. They'll really dig in, and we won't have that problem anymore, hopefully. So the mystery deepens. This is the second board, and this is the one that did not have much work done on it at all. And if you look, these are, I haven't replaced anything yet. I just took the big caps off. I'm starting to clean the glue, but I noticed that this is a Nippon Chemicon capacitor, and this is one of those orange Elna capacitors here. But on this board over here, the original capacitors were all these Nichicon types, both this one and this one. So, and they were factory. The solder had never been touched on these from the factory. So they used different capacitors for the two different boards. The other thing I noticed was this board, and I believe, well, I don't know, I can't tell, but this one has the modification for the ground, and this ground mod was something that was put on later on these to repair some of the oscillation problems. And if you notice, this one here does not have that. I mean, it's there, right there is where it would be, and it's not there. So it's almost like one of these boards maybe is not original to the amplifier and was maybe replaced, was pulled from another amplifier, like a newer one or something. And I can't really tell. But anyway, you can see I got to clean all this gook off and put a new Zener diode because it's all shot, and get this one all done just like the other one. I'm still waiting on these picofarad capacitors to come in, and they're set to arrive tomorrow, so that's probably when I'll get those, and then I'll be able to finish these up. But I just thought that was interesting. Oh boy, so which one is right? So if I look at this board, so here's the one I just finished, and I still have to put these black film capacitors I have to replace. But if you notice on the back of this board, we have this like black wire that's kind of running the same track as here. And to my understanding, that is something about reducing oscillation. I'm not sure how, but apparently it does. The other thing I noticed is over here. Take a good look at the way this thing's wired up. And now if we go to the other board, if you notice down here is an extra wire. So you can kind of see if I hold them side by side, this one has the wire, this one does not. And if you follow where this wire is going on this one, it's actually connecting the B plus, this point right here, over to right here, which is going into one of these resistors. Now on the other one that does not have it, this resistor, you can see there's the end of it. So here's the resistor. There's nothing in there. See, it's empty. There's no wire. So this resistor right here is not even in the circuit. So essentially, which one is right? The other thing I noticed is, for instance, they're using these little film capacitors here, and I believe, I forget what these are called, Mylar. I think they're Mylar capacitors. Whereas on this, they're using just regular film capacitors. And I showed you before, you know, this is a low noise capacitor, whereas it was a standard one on the other one. These diodes here, which are kind of like your stabilizer diodes, or there's 3 diodes in one pack here. Notice what they look like, how they're mounted here. You kind of can see them there. And then they're mounted the other way. You know, they're like flat there. There's just some pretty significant differences between these two amplifier modules. So it's leading me to believe more and more that either one of the boards must have burned up and was replaced with parts donated from a newer unit or another unit, or one of these boards failed and whoever repaired it made the upgrades to one channel and didn't make the upgrades to the other. We really can't know what happened. But what this means is I kind of have to stop where I am right now and look at the schematics and look through this and try to find out why these differences exist, and then decide which one is the correct one and make both channels the same. So this is turning out to be a much longer, well, I figured this would be an involved project, but now it's getting even more involved. So okay, let's dig in and see. Okay, another difference that I see is this resistor that's bodged onto the back of here. And this is that FET pack, which is a differential pair. Hold on, I'll show you the other one. And you can see on this one, it's not there. Now essentially, if you're connecting that resistor from here to here, if you flip it over, if you look really closely at the tracks, and then flip it over, essentially what they're doing is they're jumpering a 2.2K resistor across this 330 ohm resistor. So what is the 330 ohm resistor, you ask? If you look right here, there's your 330, and look at that. Now, the other strange thing I found was, well, replacing the original pot in here, the original bias pot, with the new one, the thing I noticed was the pot was almost all the way maxed out to one side. So this is probably what's causing that. Now, why would somebody have done this? I have no idea. What I'm going to do is I'm going to remove it, and then if something's wrong with the bias, then I'll go back and find out why they put this on here to correct it, because to me that seems like covering up other problems. But you know, it just goes to show these things look not serviced very much when you first look at them, but once you start digging in, you realize just how much some of these things have been serviced by someone in the past. And of course, without having any knowledge of who was in there or why or what they did, you kind of have to reverse engineer their problems and what they did. It's kind of like solving a mystery. So let me get this out of here and keep on working. Okay, so I found that these two resistors are actually important. These are the bleeder resistors for your main DC plus and minus rails for the outputs. And since this is a split power supply, meaning that it's a dual power supply, there's a separate power supply for the right channel and left channel. These need to be connected. This one was just not connected. The other one was. So what that means is that one of these resistors was bleeding down the negative DC rail when you'd unplug it or turn it off, but the positive rail, which is this resistor, wasn't even connected. So that was a factory problem there. The other thing interesting I found is a couple of these capacitors, like this one right here and this one, teeny one down here that I already replaced, which was this one. If you notice, these are those weird Mylar ones. And if you look at the other board, strangely enough, they're actually using those ones right there. These Mylar film capacitors instead of these other, what are these, polyester film or whatever? I'm not sure. I heard these are film capacitors, but I'm not sure. So obviously, when this board came out, they knew there was a problem with those black capacitors, and a choice few of them they replaced with these, whereas on the older board you can see where they just used these original ones. Now what I'm replacing with is these little tiny stacked ceramic, and they are NP0, meaning they will not drift with temperature change. They're very, very accurate. These ones are rated, I think, at either 1% or 5%. So they're very accurate capacitors, and it's really important that these don't drift. You can see, like, here's one that hasn't deteriorated. See how it's nice and shiny? But you can see what they do. They kind of shrink and dry up, and then they get all wrinkly and they start to flake and come apart. You know, when you're talking about capacitors that are, you know, in this instance 1 picofarad, the tiniest little bit of drift makes a big difference. And these capacitors, remember, their purpose in life is to prevent oscillation at high frequency. So for instance, if you look at these in here, kind of the way they're all situated in here, all of these are in here to kind of prevent the thing from going into that parasitic oscillation. And the reason that it does it anyway is because these capacitors here are just really bad ones. They failed miserably. And so by putting these new ones in here. The other thing is when they're real big and tall like that, for how small of a value, they have a very large surface area, so they're going to be very susceptible to noise and things. Whereas, so here's the old one, for instance, that was over here, and you can see the new one right there, that tiny little blue thing. See the difference? So hopefully this will help some of those problems that these amps are notorious for. All right, let me finish swapping these all out. Okay, working on this thing, we've run into another little conundrum here. And what I'm going to show you is, if you look, you have your 3 NPN transistors here, and they're all matched. They're 2 SC493s, and they're all 3 the same, and they all check the same. However, when I got to the PNP side, we had something that looked kind of like this, with these ones here, and here, over here, and this one. Notice how this is all black? That's not paint, that's tarnish. This one was just the same. I actually had to clean it off with the fiber brush, one of these. And when you flip them over, they do have similar numbers, but if you notice, this one is a 2SA1068. This one is a 2SA1068N. And if you look at the bottoms, they're different. So you can tell they're different. They were made at, at different times or something like that. They're not the same, came from the same manufacturer date or whatever. But more importantly, we're just going to do a really quick spot check with this. And I'm going to show you something. If we connect this up, I hit test, and it's a PNP transistor. Current gain is 55. Emitter voltage VBE is 0.6 volts, and of course there's no leakage. So it's a good transistor. That's what you would expect. Now let's get this 2SA1068N and connect it. All right. So if you look at that, look at the gain on that. Remember the other one was like 50 something? 303. Everything else, the VBE is a little higher. So these are different transistors. They may be from the same family, 2SA1068, but the N obviously is a high gain transistor. And it has a little slightly different VBE, but not terrible. Now, what will that do in this circuit? Well, in most instances, that probably would not make much of a difference, because really the way these are designed is they're biased in a way that they don't provide gain. This stage is really just for current carrying, for increasing the current capacity of the output. The voltage gain, there is no voltage gain in this. All the voltage is generated, or the voltage gain is generated by the preamp and the drivers and all that. So theoretically that should not make a difference, but when it comes to things like this oscillation problem that these are known for and everything, I don't know what that will do. The other thing is, it may cause these ones to hog up the current more than this one. You won't have a balanced current between the three. But again, probably not. So again, these are, these were replaced at some point in time. Obviously this thing had a failure, and somebody pieced things together to rebuild it to make a working one, and then they sold it. So these are the things you got to kind of look out for when you buy these. This thing actually would play. You could turn it on and listen to it, but really Until you get into here and start looking, you really don't know where these things have been. So we're really not going to know until we test this to see, if everything's going to be okay. But it is what it is. Okay, all the transistors here are been remounted, re-greased, cleaned, whatever. And from what I can gather, the main difference between the transistors with the N at the end and the ones without the N is, first of all, if you notice, the base plate of these was different on the bottom. Second of all, I believe the material that these are made, because these were black, they had all that tarnish on them. I have to assume, and even with them cleaned off, you can kind of see the difference. I believe this has a silver content in the metal to make it more heat conductive and more electrically conductive. So this is probably a little bit higher end version of the same transistor. In addition to that, these ones, at least from my small sample of testing, seem to have a higher gain, a higher HFE than the standard ones. Now, what does this all equate to? Because the other channel has all of these, the non-N ones. These two were obviously replaced, and they were replaced with ones that somebody found somewhere. Obviously, this amp suffered a failure in the past. It worked, but I don't know how stable it is without testing it. So we may or may not have a problem here. We won't know until we really test it out. The other thing I noticed is beyond the repairs that were made, quote unquote, a lot of the factory work on these boards was pretty poor. I mean, I normally don't criticize things very heavily, but I have to say that Sansui did not do the greatest job on these boards. On this particular board, you can see how they really tightly folded over all of the wire leads before they soldered them in. You can see every one of them is really seriously folded over, and a lot of them, I trimmed them up a lot, but many of them the leads were left very long and kind of trimmed off long, and they were almost touching and shorting in some instances. So the other thing is, a lot of these little terminals here, if you notice, they're called split ring terminals. They don't make a perfect circle. I don't know the purpose for doing that, but I've seen that technique used before on circuit boards. Just the build quality on these, it just didn't, for a really high-end amplifier, the quality control just doesn't seem to have been as good. Again, they left the one bleeder resistor completely unwired from the circuit, and I can't say that's a factory mod, because if they were intent on removing one of these resistors here, I'm off camera, I would have to think that they would have saved money on the component by not populating it onto the board to begin with. So I can't help but believe that the wire was just flat out forgotten and left off when they built it. So this is the one I added. This is the one that was correct. Now on the other board, here's the other one. Take a look at the components. So you look at these wires, you look at all these wires. Notice how none of them are really folded over as per se. They're sticking straight through the holes, and they're wave soldered on. Much neater on this. Some of these components, the solder joints were not that great. They looked dry or cold, so I've had to go through and heat them up. So there is going to be an awful lot of testing going into these boards before we even think about putting them back into the amp. So I just thought I'd share that with you. And as we figure things out, we'll probably do a separate little video on these different types of output transistors and why they're important. The ring emitter transistor, which I'm not sure, these might be ring emitters themselves, these type, but I'm not 100% sure because there's very limited data sheets for these particular transistors. We do know that they have a very high transition frequency as opposed to some of the modern TO3 transistors, and that makes them a little more rare to find. But beyond that, Just the way they're built is different. So we'll get into that in a separate video. Maybe I'll do a little follow-up on that. Anyway, let me get back to work. Just thought I'd share some of this stuff. Well, here they are. They're back together and all restored and finished. I did some preliminary tests on them on the bench, just with the power supply and so forth. You can't, because this thing uses multiple power supplies, it uses a separate supply for the preamp near the driver section, another supply for the output section, and some other off-board circuitry. Without any really serious rigging up, you really can't make this thing totally work on the bench outside the amp. But what I was able to do was just to power up the output section to make sure there's no shorts, and power up the driver section just to make sure, again, that they both reacted the same, they had the same measurements. I was able to go across the FET pair and balance them with the DC offset pot. Both of them worked perfectly. So I'm pretty confident that these are at least going to work, if nothing else. You know, I don't know about the oscillation problem or not. We'll just have to take it slowly, a little bit at a time. But I have a feeling these are going to be fine now. I'll probably follow this video up. Now, I'm going to stop this one right here, and I'm going to probably follow this up with a little bit of update, you know, a little more information on these transistors, what they mean, why this amplifier is different than some of the others that we've worked on before, and kind of give you a little idea of how this all works. All right, for now, I'm going to end this video. It's probably really long already, and all we've done so far is just the output section. And so this is part one. I wish you all peace, joy, happiness, and good health in your lives. I thank you all once again for all the wonderful comments and all the good things that you've said and so forth. And I'll be seeing you again real soon here with another video. So until then, take care. Bye-bye.